Okay, so I have this book called Applied Combinatorics with Problem Solving by Jackson and Thoreau.
Yep.
And actually, this is a class I took in college, and guess who? You know the person who taught me this class. We've done some projects from him. Any guesses?
No.
Jim Prop.
Oh,
Jim Prop.
taught that class?
Yeah, taught me this class. Okay, so here's one of the pigeonhole principle problems in this book, which is actually really cool. So I'm going to take, for example, 10 points. 10 numbers from 1 to 100.
Okay.
Okay. I didn't write this out very well, but we're going to have 10 positive integers that we pick from 1 to 100, and that's going to form a set. It's going to be A1, A2, up to A10. Okay, so 10, and they're from here. Okay. And you can even have repeats, but you'll see in a second why. It doesn't matter if you have repeats. And the pigeonhole principle is going to tell us that I can pick 2 subsets in here that have no elements in common and have the same sum. Okay, so it's pretty surprising. So let me make it very concrete. So if we just picked 1 through 10, that would satisfy the condition.
So you could.
What are the disjoint subsets? 2 disjoint subsets. So 2 subsets of this that have no elements in common, but they have the same sum.
1, 2, 1 and 2, and 3.
Ah, okay, great. So I could pick 1 and 2.
3.
And 3. That's one example. Can you give me a different example?
You could do like 1 and 10 and 2 and 9.
Yeah, 1 and 10, 2 and 9. That works real well. 2 and 9. Yeah.
Yeah.
Good. The surprising thing is we can do this with any selection we make. Now, obviously, if you have duplicates, it's super easy because if 2 numbers are the same,
You could just take those 2 numbers.
just take those 2 numbers and that. So we can pretend they're all different, or we can allow duplicates. It doesn't actually matter.
Random. So.
Well, it is random, but still, if you allow duplicates, the idea still
It could
works.
happen.
So the first thing is to figure out how many sets there are.
So you have.
So I'm going to pick 10 elements.
Let's say with repeats would be a little easier here.
So if you.
Subsets of my 10. I have my 10 element set.
Oh.
Okay. How many subsets are there of this? Well, since this isn't the main point of this problem, I'm just going to tell you. It can either have 1 or not, the first element. So that means I've got 2 choices here, whether the first element's in or out, times 2 choices here, whether the second element's in or out, all the way up to 2 choices for the 10th
So
one.
that's going to be 1024.
Right, so there's 1024 potential subsets. 1024 potential subsets.
All right.
Including the empty set. That's the one where I don't ever pick anything.
Well, that would just.
That would work.
Well, it would work, but it would be empty. Nothing's in it.
That would be.
And it doesn't really have a sum.
Yeah.
So we could define it to have a sum, but we can really say there's sort of 1023.
So yeah.
And luckily, no other set would have the same sum as this anyway, so we can just ignore it. Okay. Now, the question is, with 10 points chosen from 1 to 100, what's my largest possible sum of my 10 elements?
You have 100, 99, 98, 97, 96.
91 to 100.
Yeah, I can think of it from 91 plus 92 plus up to 100, which is less than something that's easy to add up.
1,000.
Yeah, it's less than 1,000. Why?
Because 1,000 is 10 times 100.
Yeah. So I have at most 1,000 sums. And I have 1,023 subsets. So when I push those 1,023 subsets into all the different sums, what has to happen?
23 of them have to go in categories that have already been picked out.
Yeah, so at least, let's just think it simply. At least 2 subsets have to have the same sum.
Yeah.
Okay, now the problem is they're not necessarily disjoint. Okay, so it could be that x1, x6, x7, x8, and x2, x3, x5, and x7 have the same sum. That now I have this problem. So I have two subsets and they have the same sum by the pigeonhole principle.
Yeah.
But I said they had to be disjoint also. And these are not disjoint because they have
X7.
x7 in them. So how do I solve this problem?
So
And
you can just take out X7
Why?
because it would just cancel out.
The sum would still be the same. You're subtracting the same thing from both sums.
Okay.
So if you encounter that, you could just subtract the common
So
thing.
it's no big deal.
Well, it's potentially a big deal because now I just have to be really careful. What if x7 was the only thing in this set? And x7 had the same sum as this set plus x7. Now I want to take it out, this would be the empty set.
Well, but that can't happen.
Why not?
Because these are all positive integers.
Uh-huh.
And so they sum up to something.
They have to sum up to something
This
positive.
This doesn't.
and
really
something in general, yeah.
Okay, good. Good reasoning, guys. So that's a fun example. Like, who knew that if you pick 10 positive integers from 1 to 1,000, 1 to 100, sorry,
Yeah. And the
two subsets of those 10 are going to have the same sum and nothing else in common.
cool.
Yeah, it's really surprising. That's a real interesting use of the pigeonhole principle. All right, now one more.
Alright,